So, we're talking about quadratic equations in standard form and being able to graph those things. And here's objective 2, being able to determine the effect of changing the parameters of a quadratic equation. What happens when you change the a, the b, and the c? And I think this one might be a little shorter than that first objective, which I think was kind of long. So if you take a look at this picture here, it looks like to be some sort of, I don't know, parkish kind of thing. I say that because it's park benches. But the little roof of this is made up of parabolas. And it's as if you have one parabola and you just keep shifting it and shifting it and shifting it to make the rest of the parabolas. And that's an example of what we're talking about here, about being able to change that parent function to make a new graph. So before we start talking about the parameters and stuff, let's look at that parent function. Without, notice that says without. Weird. Without the use of a calculator, we're going to graph the quadratic parent function y equals x squared. And this is something that you should burn into your brain because you're going to be doing it a whole bunch. So we're just going to make a table of values. And this will probably be the only time you'll have to make a table of values. After this, you'll just know where the points go, or you can kind of just do it in your head. So, negative 3 squared is 9. Negative 2 squared, that's 4. Negative 1 squared, 1. 0 squared, 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Look at the symmetry in that. As a matter of fact, that's the same symmetry that we see across the axis of symmetry. So let's look at the graph of that thing. So there you go, voila. So whenever you actually go to make this, you just think of this on your graph. You go negative 3, you're going to square it, oh, I got 9. Negative 2, square it, oh, I got 4. 1, square it, I've got 1. 0 squared is 0. And then I could just reflect these points across. If you don't like working with the negatives, you could have worked over here with the positive ones first. Whatever. But like I said, memorize that. Burn that into your brain. Memorize. All right. So, our quadratic equation in standard form, y equals ax squared plus bx plus c. Notice I color coordinated those because we're specifically going to talk about what each of those parameters does. When I change the a, the b, and the c, it's going to do something to our graph. What's it going to do? Is it going to make it fatter or skinnier? Is it going to flip the thing upside down? Let's take a look. All right, so I'm going to do this little investigation on Geometry Sketchpad. We're going to see specifically what each of those parameters does, the A, that B, and the C. Okay? All right, so here's a Geometry Sketchpad demo to show us exactly what each of the parameters does on quadratic function in standard form. If you have an iPad, and you've downloaded the Sketchpad Explorer app, you can open this off of my website and you can play around with it yourself and have a lot of fun. Okay, so first I have graphed in red right here. That's the quadratic parent function, just simply y equals x squared. So let's go ahead and show the graph for ax squared plus bx plus c. And right now my a and b and c are all set to 1. Let me go ahead and move my b to 0 and my c to 0. Okay, so let's just examine these things one at a time. Let's look at the a value. Right now my a is at 1, so it's the same exact thing as the parent function. So what do you think is going to happen if I make this a value bigger than 1? Let's take a look. I stretch it and it's getting skinnier. The reason why it's getting skinnier is because you are stretching your y values by that amount, and it makes it look like it's skinnier. Okay, let me make this thing closer to 0. Make it closer to 0, it's getting wider and wider and wider. And what do you think is going to happen if I make it negative? Let's go ahead and make it negative. now it has reflected across the x-axis. So positive, we have ourselves a beard. Negative, we have ourselves a mustache. So let me flap this because it makes it look kind of like a little bird. Okay, enough fun. So that's what the A value does, makes it fatter and skinnier, and then also reflects it across the x-axis if it's negative. It's going to get skinnier as it gets further away from 0, and it's going to get fatter as it moves closer to 0. All right, now let's skip down and look at C here. Why didn't I do B? Anyway, C. Let me make my C bigger. Let's move this C, and you can see as I move it, it's moving my parabola upwards. As I move it bigger, I make it smaller, it's moving it downwards. You might think that it was just the y-intercept, but you'll see that that's not necessarily, or just the y-coordinate of the vertex. There we go. But it's not necessarily. It is the x, or the y-intercept though. Look at this. This is at 1.1 and I'm at 1.1. If I move it over here to 2.74, that looks like 2.74 to me. So if I make it bigger, it moves up. If I make it smaller, it moves down. Okay, let's move this over here to C and just see what B does. So you can see that this thing kind of slides it, kind of shifts it around left and right. And its movement is actually pretty complicated. And it's so complicated that we usually don't give it much attention. We usually just focus on the A and the C. Matter of fact, when we go back to the presentation, that's all we'll be talking about is the A and the C. So let me just show you that C value is not necessarily the vertex. It is the y-intercept, but it's not necessarily the vertex. So let me move this to something, move this to something, and now you can see very clearly that it's not the vertex, but it is the y-intercept at 1. Make it whatever I want to on the B, and the y-intercept is staying 1, but that's not necessarily the coordinate of the vertex. All right, so to summarize this, my A value makes this thing skinnier as it gets further away from 0. It makes it fatter as I get closer to 0, and it reflects it across the x-axis if it's negative. Okay, my C value moves the thing up if it's positive and down if it's negative. And it's the same thing as the y-intercept. So, the A value, as we just saw, determines whether your parabola is a beard or a mustache. So take a look at this picture here. I want you to see if you can find an A value that would be positive and an A value that would be negative, and the shape of the facial hair being, well, roughly quadratic. Go ahead and pause and take a look. See if you can find one. Okay, so here's the ones that I came up with. So I'm going to say A is bigger than 0, so this is a parabola opens upwards with that chin curtain. That's kind of like what Abraham Lincoln has. Okay, and I'm going to say A is less than 0, so it's a negative, it's flipped upside down. You can have yourself a beard like, well, it wasn't even, or not a beard, it was a mustache, sorry. Upside down, and it's like that Fu Manchu. Kind of like Hulk Hogan, if you know who that guy is. His mustache. That's a perfect A is less than 0, it's negative. Alright, so this table here is going to summarize the parameters that we were talking about. Now we don't talk so much about the B, just the A and the C. So the A is going to determine the width of that parabola. And as its absolute value gets bigger and bigger and bigger, further away from 0, then our parabola actually gets skinnier and skinnier and skinnier. It's like this. It's like a weird diet where you eat a whole bunch, but you actually get skinnier. Anyway, and As the absolute value of that a decreases as it gets closer and closer to 0, then your parabola flattens out. Here's an easy way to think of this. What happens when a right here goes to 0? Pretend like it disappeared. What kind of equation do you have left over? You just have bx plus c, which is a linear equation. So as the absolute value of a gets closer to 0, then we say that our parabola is starting to flatten out and look like a line. All right. Also, if it's positive and negative, determines if you have yourself a beard. When it's positive, it's going up. And negative, you got yourself like a Fu Manchu mustache going downwards. All right, so just to avoid confusion, let's get this stuff off of here. There we go. All right. And then finally, our C. C is very easy. It's just moving your parabola up and down. C is also the y-intercept. As C gets bigger, it's going to take your parabola and scooch it up. As C gets smaller, it's going to take your parabola and scooch it down. Okay. So let's compare each of these quadratic equations to their parent functions and pretty much be done with objective 2. All right, so look at number 1. Number 1, I've got a little negative 4 right in front of the x squared. What is that negative 4 doing? Well, first of all, the 4, it's a number that's bigger than 1, so this is going to make our parabola skinnier. Skinnier parabola. Skinnier, man, that's a tough word to spell, skinnier. Basically it is vertically stretching this by a factor of 4. And when I do that, stretch, it looks like it gets skinnier. So stretch vertically by 4. All right, what does that negative do? So that negative down there reflects it across the x-axis. And that's it. That's all we have to discuss. So you got number 2 and 3 that I want you to try for yourself. Pause that video right there, and come back and check your answers. All right, let's see if I got those. Let's see if you got those right. So let's look. On the second one, I've got a negative a value. So that negative a value means I'm going to reflect it across the x-axis. And then my c value here is minus 5, which is going to translate our graph down 5 units. Okay, on number 3, don't let the f of x confuse you. It's the same thing as y. Anyway, I've got an a value of a 4th. This is closer to 0, so we're going to scrunch down our graph, and it's going to make it look wider. It's shrunk vertically by a 4th. Finally, we've got a c value of 2, which means it's going to scooch the graph up 2 spaces. So I think that I didn't mention here what the y-intercept is, so let's just take a second to do that. What's the y-intercept of number 1? Y-intercept is the c value, and the c value here is, well, there's nothing, so y-intercept on this one is equal to just 0. Okay, so it touches at the origin. All right, switch my colors here. Back to red. On this one, my c value is negative 5, so the y-intercept is equal to negative 5. And then finally, on the green example, my c value is 2, so my y-intercept is equal to just positive 2. So that's it. That's all of objective 2. Being able to take the parameters of a quadratic equation, a quadratic function, and see what they do to the graph. The a value makes it fatter or skinnier and flips it upside down if it's negative. And the c value is going to scooch our parabola up and down.